Hi, in this lecture, let us see how we can design API clients in a fault-tolerant way. Before we see that, let us first understand what factors generally cause failures in application networks. We already know application networks are connectivity or mixture of different small APIs. When I say small, different small reusable modular APIs, right? And connection of all such different APIs built in a API-led connectivity manner will form the application network. We already learned this in one of the lectures in the previous sections, correct? Now, as the application network grows, there will be many APIs calling many different APIs, especially in the process layer because it is a orchestration layer. That is where a lot of orchestrations happen. So that is the place where most of the APIs will be called to get the business outcome or functional behavior out of the experience API, correct? So this is good. Okay, this means the more number of APIs we have, that means the more we are reusing and more modular they are, the more matured your application network is. It's good in that aspect, no doubt. But one thumb rule in integration is you have to always remember this: the more the number of integration points are, the more is the chance or the risk for failures. Okay, so the more are the number of integration points, the higher is the chance for the failure. Okay, that means if you apply that particular thumb rule or formula into application network, because process layer will have complex orchestrations or may have complex orchestrations calling many number of APIs, and the more APIs we have, the small, modular and reusable, we have to keep calling more such APIs to achieve the desired behavior. That means we are increasing the number of integration points. Every API call or every call to an external application is a integration point. So there will be many such points, so that higher is the risk for failure. So these are some of the chances or most of the chances why such failures occur. Okay, so even if your application network is matured with lots of number of reusable APIs and small and modular in nature, without mitigating these failures or handling them in a proper way, it is still not that much beneficial. Okay, so we will see how or what are the different ways we can and try to mitigate these particular kind of failures in the application network. Okay, they don't eliminate them, but they can mitigate them if you apply some of the principles we're going to discuss now. Okay, let's move on to that part, how we can apply. So you already know how the API invocations happen. You know that there is an API client who calls API implementation via the API interface, correct? Which is, if you technically speak, an API client is like a postman who calls API implementation, which is the backend system's behavior sitting in a process layer or something, via the API manager, correct? So postman calls runtime manager application via the API manager. All good. But the thing is, this API implementation, at least in the MuleSoft, is implemented via three-layered architecture: experience, process and system layer. API clients always call the experience layer. Good. That in turn calls the process layer, which in turn calls the system layer. Now, like we discussed a moment back, process layer is the candidate for higher chance of the failures because of the orchestrations. So what we have to do when we say we have to implement in a fault tolerant way, or indirectly what a fault tolerant API invocation means is that during this call process, if any failures occur in the API implementation, which is the orchestration place, which is process layer, we have to try and mitigate that error so that it won't cause further cascading errors. Okay, meaning that those errors will not go and cascade or propagate all the way to the API clients and further down whoever is calling that API client. Okay, we have to mitigate such a way we handle it properly and return a proper response instead of just broadcasting or propagating or cascading the actual error all the way back. Okay, indirectly, if process layer fails, okay, using an exception or error, then it should not propagate back and cause a failure in the experience layer again. Okay, so it should not cause a throw error in the experience layer again. Suppose if we handle it properly in the process layer, return a proper response, it could be error. Maybe it's a business failure or a validation error. That is fine. We are talking about failures, not the API functional errors or the validation errors. Okay, please try to understand the difference. Failures are application failures or system failures or application failures. So those failures cause exceptions, like in JVM you can think like java.lang io.exception something, you know that, right? So we are talking about such kind of failures. Okay, so those kind of failures in process layer should not go back to experience and cause another failure in the experience layer. Okay, if we handle and send like a proper 400 bad request response back or some 500 internal server response back, then it won't fail in the experience layer. Okay, it just goes as a response and experience layer will just send the forward the same response back to the API clients. Then there is no failure on the API client side and the experience layer side. Okay, it's just like a error response going back smoothly. Actual failure happened only in the process layer. But let's say if you don't handle it, then this error may cause some 500 internal server HTTP level error in the experience layer, which also, if it is not handling properly, may cause the error in the postman, say could not parse the response or something. Okay, so which is not a proper way, and this is just a fast failures. Suppose if the failures are bit costly, meaning say if the process layer is stuck in a 5-minute or 10-minute connection establishment call, okay, to the backend system, then it should not cause the experience layer again to wait for the 5-10 minutes or again further down the API client to wait for that time. Okay, so these kind of things will unnecessarily consume the threads, cause memory exceptions, brings the systems down. Okay, so that is why we have to build in a fault tolerant way. So when we say fault tolerant way, we mean to mitigate these kind of failures. Okay, not errors, failures to happen or cascade, not happen, cascade all the way into all the APIs in the network. Okay, we have to try and mitigate at the source place only as much as possible. All right, so there are some well established approaches for implementing these fault tolerant invocations. If we try to take care of the API invocations by adopting these established approaches, okay, or combination of them, or applying wherever applicable they fit, we can apply those particular approaches in that particular API. Then these are, because these are established, they try to help and mitigate as much as possible. Let us see what are those. One way, the first one is by implementing the timeouts. Number two, we can implement retries in the APIs. Okay, before we just forward or throw the error back. Number three, circuit breaker pattern. Okay, this circuit breaker pattern is a very popular one. If you are in the Java projects especially, or if you have read the Release It book from the Michael T. Nygaard, then you would understand what a circuit breaker pattern is. Okay, this is a very popular pattern in the integration world. Number four, fallback API invocations. Number five, API parallel invocations. Number 6, cached fallback result, and last one is static fallback result. So let us see what are these, or how we can implement or adopt these particular approaches in various scenarios one by one. All right, happy learning.